Good morning, Chem 20s. We're going to start our new unit, which is called Stoichiometry. The first thing that you needed to have done is you needed to have gone through pages 1 to 4 of your workbook. This is working on balancing equations, and there's two very key points that we need to focus on before we can begin to learn about stoichiometry. Is that one, you have to be able to balance a compound. So you have to recognize that in a compound like sodium sulfite, that there's actually two sodiums and one sodium sulfite, and then 2 is balancing the entire reaction. Okay, and we know that there are 5 main types of reactions. There's single replacement, double replacement, there's formation, and there's decomposition. And then the last one is combustion reaction. And one of the things that we need to understand about a combustion reaction specifically is that if we were looking at something like C2H6 plus oxygen, we always get a product of carbon dioxide, and we always get a product of water, either as a vapor, which is a gas, or as a liquid, depending if it's an open or closed system. And so the first step when we're balancing a combustion reaction is you have to balance the carbons first. So in this particular equation, we have 2 carbons on the reactant side, so we need to put 2 carbons on the product side. Then next step is to balance your hydrogens. We look on this side that here we have 6, and on this side we have 2, and so we need to multiply 2 by 3 to get 6, so that both sides have 6. And then the last step is to balance the oxygens. So we see on this side here that we have a total of 4 oxygens, and here we have a total of 3 oxygens. And so the easiest way to balance oxygens is to go, when it's an uneven number, so this is 7, was we would go 7 halves. That's acceptable. The other thing that you could do is you could multiply out the whole reaction by 2, and so you would have 2 ethanes, you would have 7 oxygens, you would have 4 carbon dioxides, and you would have 6 hydrogens, and that would give you a total of 14 oxygens on this side and 14 oxygens on this side. Or you can leave it as a fraction, either or. I'm okay with both. I see both at the university level. So this is a very important process for combustion reactions specifically. When you're working with decomposition or formation reactions and you have a single element, so you have just a nitrogen plus something else, typically the nitrogen will be the last thing that you balance because you can adjust it according to the rest of the equation. So little tips and tricks that you might have forgotten from when we first did this. All right. The first part of this lesson that we're going to look at is we're going to look at mole ratios. Mole ratios are really important. We use them in our want over have relationships, and that is always used no matter what type of stoichiometry that we're doing. So stoichiometry is the study of the relative quantities of reactants and products in a chemical reaction. In other words, what we're looking at is we're looking at the amount of moles of reactants versus the amount of moles of products. And we kind of touched on this concept when we were looking at gas laws. The amount of moles affected what would happen according to volume, temperature, and pressure. And it says that you can use the number of moles for a given reactant or product to find the moles for any other reactant or product. And typically we're looking at the moles of what we want over the moles of what we have. Don't get caught up in this want always has to be in the numerator and have always has to be in the denominator. It depends on what we're looking for. If I want the mole, typically it will be in the numerator, but sometimes we have to invert it, and that's okay. Let's look at some examples. So in this particular reaction, so this is the example I was just showing you, where here I put 7/2, but they multiplied out the reaction, and so you had 2 ethane, 7 oxygens, 4 carbon dioxides, and 6 waters. It's the exact same idea as this. So if I put the two together, you can see that I have 7/2, but when I multiply 2 by 7/2, I'm left with 7. Okay, so that's the exact same reaction. This is asking you to write a ratio for all components, and this goes way back in the deep recesses of your minds on how to write a ratio, but there's 2 to 7 to 4 to 6. There's 2 ethane, 7 oxygens, 4 carbon dioxides, and 6 waters. That's what they're looking for in this particular step. And then it's asking you what amount. Remember, amount was key word for moles, and we see that in moles, of carbon dioxide is formed if 2.5 moles of C2H6 reacts. So this is what I have. I always start with what I have. I have 2.50 moles of C2H6. And stoichiometry really works on putting all of your math in one line and looking at how your units cancel out and what you're left with. I've done this lots of times with physics and in other parts of chemistry, but I'm really pushing you to try it this way. So 2.5 moles, it's asking me for moles of CO2. So I'm going to put CO2 up here, and I have C2H6. When I go back to my reaction, I see that I have 2 moles in this reaction of ethane, and I have 4 moles of carbon dioxide. So this is what we're talking about when we're talking about a mole ratio. We're looking at the number of moles in our reaction. So if 2.5 moles reacts, how much carbon dioxide is produced? And so we would go 2.5 times 4 divided by 2, which we see that it leads to doubling it, so 5.00 moles of CO2. And I'll show you how the units cancel out. So here I have moles of C2H6, and this is moles of C2H6. So those are going to cross off because they're on opposite sides of the fraction line. And then you can see that I'm left with moles of CO2. So that's going to be what's part of my answer. Okay? Gravimetric stoichiometry. Oh, I'm missing an example. Here we go. I was like, wow, we stepped. Okay. What amount in moles of oxygen is required to react with 10.2 moles of ethane? So again, we start with what we have. We have 10.2 moles of C2H6. The question is asking us how much O2 versus how much C2H6. So when I look in this reaction, I have 7 moles of oxygen, and I have 2 moles of C2H6, which leads to 35.7 moles of oxygen. Again, following the way that we cancel, we see that I have moles of C2H6 here, and I have moles of C2H6 here. So that will cancel out, and I'm left with moles of O2, which is what I wanted. It then goes on to say, what amount in moles of water is formed when 100 millimoles, don't get caught up in the units, of CO2 is formed. So I have 100 millimoles of carbon dioxide, and it's asking me for H2O. And this is asking for in moles, so we got to change a little bit here, but just give me a moment. Okay, so when I look here, I have 6 moles of water and I have 4 moles of carbon dioxide. And so the first thing that I'm going to do is I'm going to just do this math. I'm going to go 100 times 6 divided by 4, and I get 150 millimoles of H2O. And I'll show you how the units cancel off. We're going to look at it a little bit differently. We're going to cancel off the CO2 part. We're going to cancel off the mole part. And so then what I'm left with is millimoles of water. The question asks us, though, to give our answer in moles. So same thing, want over have. I have millimoles and I need moles. Well, milli, if we look, is 1,000 millimoles in 1 mole. So then my answer would be 0.150 moles of water. Okay, so want over have works for a number of different things that we're going to look at. Now your next task here is you're going to stop and you're going to work on pages 5 to 6.